Chemistry is about change. We got fires, we got bombs, we got ice cream melting, we got coffee, we got medicines. Chemistry is about change of matter, the structure of matter and how it changes. It's all very interesting to look at it while it's staying still, but when it's changing, that's when interesting things are happening. So again, language is important. We've got to be able to communicate. We've got to be able to use the same language as other scientists to describe what's happening. So we classify things. We classify changes into chemical changes and physical changes. Now, in a chemical change, you've made something new. You've taken some molecules and broken them apart and rearranged the atoms to make something that you didn't have before, a new substance. Here's an example. We've got a hydrogen molecule here with 2 hydrogen atoms, and another hydrogen molecule, and an oxygen molecule. And then the arrow means that we change it. There's a chemical reaction, and we break up all those bonds, and they stick together again to make H2O, water. You see, we got the same, we got 4 orange atoms going in, 4 hydrogens. Got 1, 2, 3, 4 hydrogens coming out. 2 oxygens going in, 1, 2 oxygens coming out. We broke apart the atoms, the molecules, and then stuck the atoms back again to make different molecules. We made something new. It's a chemical change. Now, there are changes in chemistry where you're not making anything new. It's the same thing, but it's just different. It's a different thing. It's still, there's a physical change. You still have the same substance, the same thing, but the physical properties have changed. I think of it as it's the same thing but different. For example, here we've got some little blue atoms, and they're all close together, staying still, or nearly still. It's a solid. It's a solid block of atoms. We change it, and now the atoms are flying around all over the place. It's a gas. They're the same little blue atoms. It's the same stuff, but it's different. It used to be sitting still in a lump. Now it's flying around. That's a physical change. It's called sublimation, where you go straight from a solid to a gas. We'll talk about that in a minute. So let's get some examples. Let's start with physical changes, because they're the easiest to get your head around. A piece of paper. If I tear the paper, whoops, it's still paper, but it's different. It's the same thing, but different. If I crumple it up, still paper. It's the same thing, but different. If I stick it in the water, it's the same thing. Eventually it'll go all soggy and yicky. It's still paper though. It's the same thing, but different. However, what if I set fire to my piece of paper? What happens to it then? Well, we've got light, we've got heat. Ouch! This is where I always forget that I have to do something with it. It's hot. We've got a color change, and you can smell something being produced, a gas being produced, and we end up with something quite different. We end up with this ash. Have a look. It's all crumbly, grey. We made something different. So burning stuff, that's a chemical change. And these are things to look out for if you want to see if you've had a chemical change. Now that, a bit of a strange one here. The next physical change we've got dissolving. Dissolving's kind of, you've got to think about dissolving, which is is why we do chemistry, to think about these things. Got some water. I put this solid salt in it, right? Salt. This bit of burnt paper in there, which is sad. Give it a stir. So you're going to have to ignore the ashes that I dropped in here. But as I stir the salt in, it disappears. Okay, well obviously it didn't really disappear because that only happens in magic. And there's no magic here. What's happened is it's dissolved. And it's still salt. If I were to taste that, it would taste just like salt. It's salty. It's still salt. What's happened is it's broken up into tiny little pieces and they've mixed in with the water. We've made a mixture of the salt and the water. And the pieces of salt are so small you can't see them. If we wanted to separate that mixture, I could boil the water and turn it into steam and it would all go away. And we'd be left with our salt at the bottom. So dissolving is a physical change. Now I'm going to stand up for this one because I don't want to get this all in my lap. I've got some acid. We often talk about acid dissolving things. I've got some metal here. This is magnesium. And I've got some pretty strong hydrochloric acid. If I pour this in here, and then drop in the magnesium. I don't know if you can hear it hissing. It hissed and it bubbled and it's gone. There's nothing there. Did it dissolve? We always say acid dissolves things, doesn't it? Well, actually it didn't. It didn't dissolve. It reacted. You saw bubbles. It was making a gas. It was making something new. Gas produced, a sign of a chemical change. Watch out for acid, because it actually reacted with the metal and turned it into something new. And my last demo is a precipitate reaction. A precipitate reaction. Stand up again, because I don't want to pour it all in my lap if I spill it. I've got a nice clear liquid here. This is potassium chloride. Everything's dissolved. It's a solution. You can't see anything. It's all mixed up so small you can't see it. And here I've got lead nitrate. A very dilute solution of lead nitrate. It's also a clear solution. You can't see anything. But if I mix them together, nothing happened. That wasn't supposed to happen. I knew I should have tried this first. I'm going to keep going and give you another video of a lead nitrate reaction. Strange. It's just been summer. Maybe the chemicals have gone off. I don't understand. Let's put some more in there. Okay. Some more of this. This should be a very spectacular reaction, but it wasn't. A precipitate reaction is where you mix two solutions together and they create a solid. And you see this cloud of solid appear. That's a precipitate reaction. Again, you've made something new. You've made something that wasn't there before. Cooking is an example of a chemical reaction. Cooking's all about chemistry. It's all about making something new. That's why we do it. We don't like eating raw chicken, so we cook it and make it into something we want to eat. Changes the state of physical changes. Wherever you're boiling or condensing, boiling a liquid to turn it into a gas, or condensing a gas to turn it into a liquid, You've got the same thing, it's just different, like the example previously. If you're freezing, melting, or subliming, you've got the same thing, it's just different.